So I just kind of want to start in kind of the beginning. Can you tell us a little bit about your story on, what got you into thinking about starting a company, maybe even earlier, like what got you into computer science in the first place, like, or maybe cryptography, like how did you get to thinking about what eventually became Ingonyama?
Right. So my roman with cryptography goes way back. I mean, I don't have a good explanation for that, but I always had a thing with cryptography. Starting from these very high-level books, but eventually I knew that I need to understand more about the theory, which led me to take PhD route to kind of like dive deeper into computer science, math, complexity, cryptography, to understand it better. And indeed, like the other part of at least my equation is being an entrepreneur, right? So these are like two things that not necessarily go hand in hand, but it's another thing. It's another kind of like thing that always been there for me. I mean, I've spent quite many years in Israel in intelligence, and it might seem very different, but obviously, first thing is I always inspired to involve cryptography with whatever project I was working on. And second, I always found myself in this position of innovation and trying to find something new. I mean, so it is, back in intelligence, it's mostly about resources, like you need human resources to convince this. I mean, when you convince this, kind of like what you get. In real life, you get money, right? So yeah, I mean, eventually, my last hope before I started Ingonyama was another crypto company or another startup which I founded, and where I worked on this intersection of infrastructure and cryptography engineering. And I knew that this is it for me. I knew that this is like my passion. I'm kind of like, this is it. Now, the one optimization that I could have made was that my previous company was a consumer-facing company. So there's very little you can do at some point when the company is going with actually, to keep the cryptography innovation. I mean, you want things to be kind of like stable as much as they can, and focus on other things. So eventually realizing that I left this company, which, very deep part after founding it, but immediately it became clear what I need to do next, right? So with zero knowledge, just like with any other technology, when it gets to, or when you want it to go into mainstream, you need the software, you need the algorithms, you need the hardware. And for zero knowledge in general, privacy enhancing technologies, it was very clear that hardware was missing. And for me, it was a very sweet spot, right? So I'm kind of like pushing on my passion for working in this, like, building infrastructure for cryptography. But now instead of focusing just on software, we start from the hardware and do the full stack of hardware plus software. So yeah, I mean, it was very, it was very clear for me that like this is what I need to do.
And in that area, especially when there's something so that others haven't done, and that seems so like a strong potential for you, but because the market hasn't yet done this and there isn't yet demand for a product, you have to take a very big leap and have to reason through the risk profile. What sort of gave you the conviction to know that this was going to develop into something very significant, or how much of a risk do you think you were taking? It's always very different in every startup, what you think is going to work out or how the market is going to evolve. But like, what gave you sort of like the conviction? How do you think through the model to figure out like, oh yes, this is definitely going to be the future. There's so much here that this entire ZK field is going to grow into and explode eventually. That gave you the conviction to go get started on this.
Yeah, I mean, so first of all, we're still not out of the risk zone. I mean, I wouldn't say that we are a successful company. We're always, trying to challenge ourselves and keep pushing and shipping and execute with a velocity that hopefully is just accelerating. But at least the initial conviction first came from my network, right? So, for example, Justin Drake, right, like is let's say the godfather of Ingonyama. I mean, when you hear him talk about like the future, what's going to happen in 5 years, in 10 years, and you let yourself like be open to these kind of conversations and imagine how the future is going to look like, it's very clear. I mean, in our specific case, as I mentioned already, one thing is, just like with AI and other kind of like major technologies, you have to have this kind of like important level of hardware, but also ZK fundamentally removes trust from a system, right? And I was already in a place where I worked in this space, like I've seen, like, the mission that all of us take is basically about decentralization. I knew that ZK right now it started from blockchain, from Web3, because we are lacking this assumption of trust, and we simply don't have it, right? So we are forced to work with these technologies, but anyone can use ZK and other such technologies to remove trust. It can be any kind of like Web2 corporate. So basically I see this kind of like, diffusion in the next few years. So it was very clear to me that one, the answer is going to be in hardware. I mean, processors today, CPUs and other accelerators, simply not good enough and are not designed to support cryptographic applications. And the other thing is that ZK is, like the nature of ZK is that it's going to diffuse over time and going to be, going to impact, like basically it's very fundamental technology, going to impact any vertical that would want, to remove what we already seen in the space, but we know it's going to be elsewhere as well, just remove this like centralized risk from systems.
Yeah. So, and yeah, thank you. And as you got started and you started building Ingonyama, how do you think about productizing the technology? What were some of the first things that you tried? Maybe talk about any kind of early successes or failures. How did the product development go?
Yeah. So the original idea was to build a semiconductor company, and at least initially I thought it was going to be like the classic way to do it, which means you do some design, like for the hardware, you implement it first on FPGAs, you find some traction, some early demand from customers. Once this demand increases enough, you go to an ASIC, and from that point on, you basically kind of converge into Moore's law. So as the technology matures, there are cycles, and each time we develop a better and better chip that can give better performance to customers, which we hope, again, want to be everyone, because I imagine this kind of like silicon in phones, computers, anywhere, right? Now, this is, was too ideal, right? So obviously the market is not there, which is one thing. And the other thing is that you learn about what it means to actually build an acceleration for zero knowledge, right? So originally we thought, similar to what you have today with AI, what we have with AI and matrix multiplication, we thought, okay, so we have this like big computational bottlenecks, let's remove those with acceleration and we're done, right? But it's not the case, right? You need to do much more than that. You need to think about how the memory is structured, how the data movement, the bandwidth, the I/O, and all of that. You need to actually build a full-blown processor that is also going to be programmable, right? Remember that ZK is still extremely active field, right? It's like a moving target, and with hardware, like you need to add programmability to kind of like support all of these like use cases. Basically, what it got us to realize as a product, first is that we need to focus on the existing hardware that we have today. I mean, the hardware is actually the boring part, right? Again, eventually it's going to converge into some Moore's law, and then once you have the design, I mean, you can always optimize it more in the next chip. The software part is harder. I mean, how do you get people to actually adopt a new processor, a new paradigm? You want it you want the developer experience to be very smooth. You want to have adoption already there. So that's what we focused on. I mean, we're just building software right now. Most of the team is actually focused on software, and not just software, also very high level like we can put more emphasis on the API and the high-level Rust, Go language APIs than the actual performance. I mean, you really don't care if it's 10x or 11x, but you do want your developer to have a very kind of like good experience integrating with acceleration. And then we went with existing hardware devices and appliances, right? So it's GPUs using clouds, it's FPGAs and so on. And we've just learned more about how these can be programmed and developed on the one hand IPs that can be used with FPGAs, and also for GPU. This is kind of like a general purpose library that will allow developers to either port their protocols or products, parts of products dealing with ZK, or just implement. I mean, if you are from academia, right, just implement directly on GPU. I mean, why spend time writing for the wrong hardware, like CPU? So that's kind of like the trajectory too.
Yeah, and can you maybe talk through some of the use cases that you see up ahead, that maybe people that you see in the horizon that you don't yet see people doing or owning yet, but that you think are now becoming possible, whether it is using that software or others, or things that you are sort of excited about in the frontiers of ZK?
Yeah, I mean, the first thing that when you think about hardware is to enable. Okay, so if we take an analogy from GPUs for gaming, right? So until GPUs were able to render at a fast enough speed, image, they were not really useful, right? So it's about enabling new use cases, and that's kind of like what hardware can give you, right? And eventually, this is the scale that we are looking for now. When we are thinking about next year, first there are a few exciting chains and L2s that either launched mainnet or going to start to incorporate provers in like decentralized way, which is very interesting, and we try to contribute to that as well, of course. Also, chains with privacy baked into them, like Elio, like as a first-class citizen, and obviously privacy here is based on ZK. So these kind of like things that are more of like the short term, it's pretty hard to predict how the prover networks are going to behave, because it's not necessarily going to evolve into a proof of work type of, like Bitcoin type of networks. So it's not really predictable. It might be something new. And then there is like more of the long term, right? Just a conversation I had earlier today is about like with AI. So what you have today, like if you're a data scientist and then you want to work with AI, is, I don't know, you have your Python and you just like build your model and you run it. You say this should run on GPU, whatever. You don't really think about it. And you want the experience to be the same, right? Like you want, or the way you see ZK here is as a feature, right? Like, so we want data scientists, and it can be others, right? It can be, I don't know, game developers, can be whatever. Anyone should be able, in their respective kind of like development environment, to be able to say, oh, now I want a proof that goes with this matrix multiplication, this like whatever math computation, this function. You just say, yeah, here add a ZK proof, and you are done. And the challenge is to kind of like match the expectation, because you want the proof not to be as a standalone. You want it to be actually part of the output that you get, and you want it to be fast enough so that the experience will be good enough. So I think that, right now, somehow the entire space, I mean, almost everyone that talked today is talked about middleware and infrastructure, and I think it's for a purpose. Like something like, intuitively we feel as a collective that these things should be get better and better and enable, as I said at the beginning, and enable new use cases and applications. So I think that the really exciting use cases are still very far from where we are today, but we think in a very healthy way about how to enable them. So I just mentioned AI, which I think, accountability for AI and verifiability of AI would be critical. And yeah, I mean, we can go over like many other examples, but the important part is that for all of them, there's like this good like infrastructure and tools that are being built today to enable them. And I think about them as features. Might be that there are different ways to think about them, depends on the context.
a lot of computing cloud style products have gotten very successful over the last couple decades by simplifying the process of writing some code, some business logic, and wrapping it in a very easy way to schedule that computation and run it. In blockchains right now, we're exploring scalability by having lots of groups build these very large chains, and maybe we're starting to get to rollups and a few L2s and so on that are kind of scaling this. But we're still very far away from the fluid scalability that the cloud traditionally has had. When you get a few thousand or a few tens of thousands of machines, you put like a VM in it, and you put either different containers on it, or even better yet, you put like V8 in it and you put a bunch of JavaScript functions and workers inside. What seems to be missing to me is like some concrete way of making that computation verifiable. So when are we going to get like ZK containers or ZK lambdas or ZK like these kinds of very easy pluggable functional units? So then, sort of like scale all of the computation here much faster. Like, what do you think is missing?
No, I can just like resonate what you just said. We actually just released over the weekend a product announcement called ZK Containers, which basically thinks in kind of like similar lines. We have best practices, like we have all of this like wonderful infrastructure that works extremely well for scaling with other industries. And become a kind of like a standard. And I think we see now this kind of like movement to adopt and kind of like see how it works when you think about ZK. But yeah, I don't really have anything to add on top of what you just said. I mean, I have the same kind of like questions. And for us, I mean, when I have these questions, basically my team and myself, just sit down, we read, we try to come up with strategy and try to project what we think is going to happen. But for us, this is like very early in this journey. It's just something we started not long ago to conceptualize.
Yeah. Awesome. Well, maybe like thinking ahead a little bit, and I'm going to ask a couple more questions, and I'm going to open it up to the room. So start thinking about what questions you want to ask. Maybe a couple questions. So one is, what do you think about other cryptography areas like FHE, like fully homomorphic encryption? Do you think it's going to follow a similar path to ZK, just kind of a little bit, further out in the future, or do you think, how do you reason about it?
So personally, I'm extremely excited about fully homomorphic encryption, and we've been actively working on this field. Now, what I can say is that it's different than ZK. So recall that I told you that ZK has this like, impact on decentralization, right? So with fully homomorphic encryption, it's basically an encryption, right? And unfortunately, the way I view it today is that it's much more IP intensive than zero knowledge. So because maybe, I don't know, I don't have a good explanation for that, but maybe because zero knowledge was developed over the last decade, mostly in the space, we don't have this, like, I mean, no one is going to win or going to kind of like have like an IP claims here about anything. It's kind of like we work on this together, and that's a beautiful thing. We don't see it quite often in cryptography, and that's very sad. Now, with fully homomorphic encryption, the way that I view it is that there is much more IP already, like patents and all of that. And this is kind of like how it's going to be, how it's going, right? So first, in terms of like the DNA of how this technology will mature, it's just a bit of a different in terms of DNA. Also, and again, because we've been pushing ZK in a very impressive way, we see amazing results almost every day. Fully homomorphic encryption main target is right now outside of Web3. I mean, of course, we talk about it in the context of Web3. We want to see how it's being used for privacy and together with ZK and all of that, but it's also going to be extremely impactful. I don't know, just imagine with today, like ChatGPT, like all these LLMs that running at some like remote server, I can just encrypt and send it, and it will be processed, like the data going to be encrypted. I'm going to get like the ciphertext and decrypt it. It's fantastic. It's going to save a a million problems, right? And by the way, it's also going to be pretty much a game of hardware acceleration, which is going to be critical here. But yeah, I mean, we do want to see, or maybe we might see that the adoption starts from more the Web 2 kind of like data centers, and then also go into what we have in Web 3. Maybe, I don't know, just my opinion, or I'd like to also hear what you think, but that's kind of like two differences I see between ZK and full node encryption.
Yeah. And what are your thoughts on AI? When are we going to get, I mean, you mentioned it a few times already, but as you look ahead to some of the improvements that we're seeing dropping from the AI community over the last year or two, and you maybe think ahead like 2, 4, 10 years out, how do you think that's going to both open up application space or even change what you're doing directly, what we're all doing? When are we going to get like models writing the ZK applications themselves or the foundational SDKs and whatnot? How much of this are you tracking? How much of this are you excited by or worried by?
Right. So two things I can say. One, since at least with all of these new advancements in AI, obviously us as a company, right? So from my personal experience, we've been using it extensively. Like we've done this hackathon around ChatGPT a while ago, and in general AI technologies. So to make sure that everyone, like literally everyone, including HR, including everyone, basically is using it on a daily basis, and we got these tools and we keep them updated. So this has definitely become part of our life. Now the question is, how do we get ZK to be part of? There are two. It's like two directions. One is when you think about ZK and AI, how we can bring AI to ZK, and also how we can bring ZK to AI. Right? So what I mentioned before is that when you look on a big, very energy-consuming AI system, so ZK is probably going to be a feature, right? Full homomorphic encryption as well, kind of like maybe something like the feature. The thing is that this space, like the AI space, is moving so fast, so it really requires a lot of motivation for someone there to actually say, "Oh, I'm going to actually buy into that." And then the question is, how is it going to evolve? So regulation might be, there was this executive order recently around privacy with AI. I mean, there might be this kind of like, regulation reasons that will just force AI to start to use more ZK kind of tech. There's also might be some real damage because of deep fakes and all of that would kind of like make the best practice to, you need to watermark this and that, and ZK is becoming like a very standard way to do that. So that's kind of like might be the door, the door into incorporating that. The other way around, by the way, it works nicely already. Like we have a lot of hype, but also many companies doing already, like bringing AI on chain, which is fantastic, and it's going to be, I'm sure, going to be like even next year we're going to see actual products that are using it, actual protocols that are using AI on chain, and it's going to be beautiful, and I'm looking forward for it.
Yeah. Awesome. Well, any questions from the audience? Raise hands and we'll get a mic to you. The first one is always, yeah, there we go, Hector.
Yeah, congratulations on getting new funding for your ASIC project. So when is your chip coming out? What's the plan for that?
Yeah, so about ASICs. First, there's a question on how semiconductor companies are making their first steps. And I'm going to argue that it's basically about luck, okay? And it's our goal to make sure that we are positioned in such a way that luck finds us, okay? Because obviously, as you can imagine, no one, like no big VC, is just like walking around with a check size of $50 million, $100 million. Because if you want to beat like latest GPUs, with at least the ASIC that we imagine, which, as I pointed out, programmable and so on. And it's going to cost a lot, like you need the latest technology and such. So no VC is just like wandering around and trying to think where you can invest this, I don't know, big check when there's no real market. But on the other hand, as I mentioned, ASICs are going to be enabled, right? Because if you have ASIC, it might be open, you can open up all these new use cases, so it will grow the market. So really, it's like chicken and egg situation. Therefore, it's going to start from luck. So for us right now, it's less about, or at least the way that I've built the team is to become, it's a very diverse group of generalists, and we try to stick with the market. And I mean, obviously, to educate and do our part and at events, to bring everyone together, but also to try and help, like to do this kind of like tide where everybody can improve their products. So today we understand the needs and we try to make sure that any company that wants ZK acceleration can have access to it. It should be open source. It should be very easy to tap in. It's just a few clicks to move from CPU to GPU. Now, once you pass this barrier, then it's a matter of, okay, I mean, we can jump in technologies according to market demand, and then and at some point, eventually, have this like ASIC that we imagine. So, I mean, it's a very long answer to say that I don't have a date for a tape out, if that's kind of like the essence of what you wanted to hear. And the way that we try to think about it is basically taking steps, not just to say, meet me in 2-3 years, I have a chip, I don't know if it will be good for you or not, but to make sure that we at any time assess both the risk and also the opportunity, and make sure that everybody around us can benefit from acceleration today. Okay, that's what we care about. And I hope that ASIC can be very soon part of this, like ASIC tape out, not just design and building IP cores and do small chips and all of that. Like actually do the full-blown ASIC is going to be part of our roadmap very soon. But yeah, if you happen to have 50 million check, let's talk afterwards.
Right, back there.
How are you thinking about the distribution of the ASICs so that you distribute it in a fair way to service providers so that you don't have centralization?
Yeah, that's a good question. So maybe at one, there are even like a few dimensions, right? So one level here is that obviously if we want acceleration on your mobile, so it's not like Apple are gonna have another chip inside their iPhone, right? So you need to think in terms of what's the best way to integrate to kind of like build like Pico that helps them. So it might be led by some kind of like decentralized identity or some kind of like a very specific use case that is of interest to them. We also see, I mean, there are places where we start to see this kind of like, for example, with computers, with laptops. AMD started or will start to ship laptops with AI engines, which is a very powerful technology for ZK acceleration. So we right now we're still relying quite a lot on the distribution, which is already in place. iGPU is commodity hardware. So we rely mostly on the distribution that's already in place by these like giants like NVIDIA, AMD, Intel, and hopefully Apple, Samsung, and the likes. Now, the question is, what will happen once there's going to be a chip? And it's a good question, because remember that these chips are dealing with security and privacy. So just the geofence between China and the US is going to create one issue, right? But there are many other such issues. So going back to my argument about we start from software, I would first make sure that everybody adopt best practices and easy way to, and maybe there's kind of like, there was a talk today, kind of like having this like standard API working with hardware. So we start by kind of like making it easy to integrate with hardware. Then obviously you want to make the price of the chip very low, and you want to make it accessible. Now, I don't have good answers for that yet, but it's going to be a challenge. I mean, this is something, I don't know, maybe Juan has some ideas here on centralization for the semiconductor levels, but it's a definitely good question.
Would the focus be more on clients, so more on consumers, or like big service providers that would be crunching a bunch of these tasks?
So this is just my opinion, but I don't think like we need to focus just on one of them. I mean, I see also this like training in academia on how you can even have privacy when you use servers, right? Like MPC plus zero knowledge. So it seems like shaping to become a reality very soon. So in theory, like data center can cover all of the use cases, both of scaling and privacy. In practice, I really hope to see, client-side zero knowledge. For example, with gaming, I think it's going to be crucial because it's going to fight like the data. Like you want to also remove some burden from the data center to save some money. I mean, there are different reasons like why you want to do client-side. So, I mean, according to what I said before, the goal is to and maybe it's not just like my company, obviously other companies, and we have many companies focusing on that area at this point, would do client side, but also like server side.
Hello there. I would like to ask how future-proof the general methodology in ZK systems are. So let's imagine the mobile phone of the future. By 2030, if my published predictions are correct, we should have a 5 petaflop per second, 20 watt mobile phone that has a really advanced GPU inside, miniaturized, and that would be equaling the current top GPUs today. And it would be able to run, advanced AI software and some other stuff. So how would the equation change in this case? That's my question.
I mean, I'm not sure to what equation you are referring to, and also we have to compare notes about where we will be in 2030. But basically, first, maybe I wasn't clear enough about that. The GPUs are extremely good when it comes to running ZK workloads. I mean, definitely there's room for improvement. And as I pointed before, there's Moore's law in a way that you can imagine how we converge into some kind of like growth, growth with technology. But the GPUs, and if anyone would ever want to have an ASIC, it should be better than a GPU. But GPUs are not static. I mean, they keep improving. So right now, if you try to project it to present time, you have GPU, and that's kind of like, let's say, GPU, FPGA, whatever, like state of the art. And we are growing, like the performance is going to improve on the hardware side at least with the changes and the updates to GPUs. There's one trick which we didn't really get to as an industry, which is to do hardware software co-design. Right? I'm going to tell you the restrictions that I have for the GPU, and then we're going to come up with this algorithm and protocols for ZK that are more hardware friendly for the GPU or for the FPGA. Right? So that's like another kind of like a boost that we can have. But eventually, steady state, it's going to be a very predictable kind of like change. And at some point, it will cost some critical mass, whatever, and some applications will become possible to do. And then we might see some jumps, right? So if there's a specific use case that is critical for mobile, there will be an ASIC for that or some IP core for that, and you can see a jump, right? It's going to lower the power consumption, it's going to make latency or throughput like way better. I'm not sure if that's what you meant, but that's kind of like the way I see it. Bottom line, hardware is predictable, right? That's what I'm trying to say.
All right, thank you. I think we're a little bit over time, so let's stop there. Omer, thank you so much for sharing your time with us, and thank you for putting on this awesome event.